Hey, what's going on? This is Scott Perry. In today's video, we are going to take a bird's eye view at the system I've designed to integrate Traktor into Touch Designer. We are going to create custom lighting sequences to play back in time with songs in our DJ software using Touch Designer's animation comp. So there's a lot of ground to cover. We won't dive too much into any specific code, but just kind of gonna go with an overview, description of how it works for me and how it can work for you. In some later videos, we will dive more directly into specific topics, but for now, let's just see how it works. In this case, we are going to be able to load predetermined time-coded lighting sequences into any of the decks on Traktor, just the same as we would in a regular audio performance. Once the sequence is initiated, you launch lighting pulses, events, as we've discussed in video 1 of the Timecode Touch Designer series, to any of our banks of lights, and as the song progresses in Traktor, the lighting sequences remain locked in time in Touch Designer. Let me show you what I've got going on. Up at the top of your screen, you'll notice a UI that features a line across the top that represents 32 cans of LEDs that we use for wall washes. The grid here is indicative of our LED infinity mirror dance floor, which has 96 tiles, and each tile has 28 pixels in a square. From there, to the right, we also have 8 16-pixel Titan tube, Astera Titan tube fixtures that we use at a lot of our events. So each of those can be toggled on and off with the a hue that we set inside of our events. But before we get to that, let's just dive into a little bit of how the handshake between Traktor and Touch Designer works. To the right here further, we have a playlist that has some of the time-coded sequences that I put together, and the decks here on the right-hand side even further are indicative of the settings that we have live in Traktor. So as I scroll through the playlist, if I hit the encoder down, it initializes the system. Now the next song that I load into deck A, in this case, is represented on the screen. It will make our system go active as indicated by this green light on deck 1. And now when I send the audio here, it should all be locked in time, and send through our UI. You can see how the sequences work. A little fast. Let me slow that down a little. Day and night, I toss and turn. We also have discrete control of the stems. So if I turn off the drums, it doesn't make the drum light pulses. Play. Now look at this. Madness, the magnet keeps attracting me. I try to run, but see, I'm not that fast. I think I'm first, but surely finish last. Cause day and night. So each time you see a new pulse of light that is sent from an event that's being pulsed from an animation comp that we have customized using a really cool component called the Keyframer. More on that in just a little bit. First, let's talk about how we can get signal from Traktor into Touch Designer to keep our decks locked to the beat. This next screen features the controller manager of Traktor next to the MIDI mapper panel from Touch Designer. The premise of this project is to have Traktor controlling Touch Designer with its native functionality. So if a deck is playing and it's up, the volume is up, then we want to be sending events. If it's looping, we want to know that. If it's loading a deck, we want to be able to know that as well. So there are basic ingredients that we need from Traktor into Touch. In order to do that, we use LoopB internal MIDI application, and we wind up sending out of the port in the controller manager a signal every time each of these occur. Basically, you can go through this list and see that I effectively mapped channel 0 and channel 1 and channel 2 and channel 3 to play pause for each of the decks. And then progressing onto the select and set store hot cue A, B, C, D, 4, 5, 6, 7. And that progresses quite a bit for all of the effective ingredients that we need. And then when we go over to the MIDI mapper, you can see that here we have our 15th device mapping is set to be Traktor 3. And if I go to the devices here and click on Traktor 3, this B1 button is set to the number that comes off when I hit play. So I'm hitting play and pause on my track deck 1 right now, and you see the number that's coming out of it, B00, 007F. So you have on as 7F and off as 00. And then you just kind of go down the list and fill out the subsequent channels. When it comes to the channels that we map from Traktor into Touch Designer, the channels that we select are a bit arbitrary. As long as they match in both programs, we are good to go. So now that we have all of our channels matching, the next objective is to create custom parameters on a base component so we can have access to the input signals from Traktor. We're going to want to have a script run inside of this base to change all of the parameters as the signal comes in. So we want one line sleek little script to use the names of these custom parameters. So we pull in all of the channels in a MIDI and mapper chop. And then some of the channels, we do a little bit of math to multiply them by 127 to get an integer value. We rename the chops channels to match the associated custom parameter. And then we use a chop execute dat with off to on and this Python script to change them dynamically as the channels alter. We use the same script once again, this time in a chop execute dat with the value changed method. We can't use off to on every time because settings like loop size never go to 0. The nice thing about having these values on custom parameters is we can use a global op shortcut to grab these values anywhere in the network, and it only cooks when it changes. Now we'll head over to our playback component that I have created to mimic the decks of Traktor in Touch Designer. The deck 1 is kind of our master component here, and the deck 2 through 4 are clones as set in the clone master parameter. we have set up custom parameters to mimic the information we're receiving in our Traktor communications base. We use binding here using global op shortcuts to alter these parameters, because while we definitely want Traktor to have control, we also want to have exclusive control within Touch Designer. There are times when we want to say things like op.deck1.par.q equals 4 to see what's going on in the fourth section of a song. And a lot of times we're operating without Traktor even hooked up. So using binding here is a good method to maintain independence from both sides. Now we go inside of the master deck component, and we need to build an independent timeline to lock in the beats from Traktor and the timeline in Touch Designer. From there, we're going to link it up into an animation component and shift through all of the nuanced events throughout the song. To demonstrate that this is all linked up, I'm going to just cycle through some of the hot cues in Traktor. You can see the deck in the lower left-hand corner is changing, and also the parameters on the deck base there. You can see Q changing on the top right-hand corner. And as I hit play, I'm going to click on this advanced song beat here. I have these parameters set on my each deck to demonstrate what the number beat in the entire song is. So if in this case the deck is playing and the deck is active, then we will advance the beat count. If you recall from moments ago, we have these buttons at the top of the UI that indicate the active status of a Touch Designer deck. We choose to turn them off completely for portions of our sets where we don't have preset time-coded lighting sequences. This just stops the whole thing from cooking and saves us a big chunk of frames. So that is a simple script that increments the beat count every time the value changes in our null advanced TC timecode chop. So we have an understanding of how the beat count works, and we have an understanding of how our hot cues work. But I wanted to show you this parameter right here, the section. A section is just a variable that I have defined myself, which equates to a part of a song that would be like the chorus or an intro or a bridge or a verse, something like that. And I have created a dictionary that has these 5 keys, and then the values are down here. I don't actually use QType right now, but I have aspirations to check if it's a loop or something. At one point it worked, but it wasn't really necessary, so I've kind of abandoned it. But the other ones are hooked up, and each section has a hot cue, a name, a period, and not necessarily every section has a hot cue. You can have a section in more than 8 sections in a song, but they are all defined here in our UI. If I click through the songs of my UI, I can then also address each of these sections. So we're in Kid Cudi right now, and if I change the name of intro to outro, I like to use colors just to make sure that I can see that it's changed. Outro black. We are seeing in our DAT here that outro black is the real name. I'm going to change it back to intro because that's what it really is. And then what I'm doing here in this sequence of DATs is trying to find out what beat of the song, what beat count is referenced or equated to the beginning of each section. So if I change this period to 64. You can see here my beats have all changed to count down, well, count up in this case. I'm going to change it back now. So if you watch this period here, now my dictionary has changed internally and the referenced beats are back to the real section periods of the Kid Cudi song that we originally had listed. Why does that matter? I'm referencing the sections here to figure out at what beat count will this go off to on. And then here I increment my section. So we've seen how the beat count goes up throughout the progress of the song. It also changes when we are clicking a hotkey. A hotkey switch in Traktor will change the hotkey parameter, the section, and the beat count at the same time. Okay, we've talked a lot about these sections here. If you go to these lister panels in our UI, we have the sections of the song laid out. And as we click on each one of these, the next panel over here shows each of the events that are programmed for each period of a section. You have the name, the trigger. These triggers are associated to the triggers that we have coming off of our keyframer component made by Keith Lestracco. He made the successor to the animation comp. I was doing a little bit of research trying to polish this program up for public display, and Greg Ermanovich from Derivative was commenting that this was one of the best advancements in the animation comp that's come along. So I took it for a spin and kind of rewrote a lot of what was going on with my program up to this point. Really glad I did, because it has some awesome copy and paste functionality, as well as Control Z, undo, and redo. And it works well in the panels of a UI. So if you've never seen it, take it for a whirl. It's well worth checking out. But moving on to what's happening in these sections, I've got my hotkey number 2 loaded up here, and as I progress, you can see right now our clap is happening on our tubes, but if I add it to the cans, I can have a clap happening everywhere. Or make the kick drum happen on each of our fixtures. And then as we are counting onto the beats, it switches. And now we are on to our next section, which has these settings in our parameters. So I'll just keep that really quiet now and show you that if you left click on these names, then all of the presets that we've created in our list are available to pick, and we can kind of change them as we go. These triggers are the channels in the associated animation, as well as some of our pre-programmed basic on-off. This kick is 1 and 3 beats of a measure. Snare are 2 and 4. 4 floors every 4 single beat of a measure, and clap happens once of every measure, and you can shift what beat that's on. Then our slot is associated to a stem, so we can turn off a stem in Traktor and then the beats don't happen. The duration is how long each event lasts. Our intensity is float from 0 to 1, and the tail is how long the pulse of light is relative to 1 unit. So if you have a tail of 0.25, then 1/4 of the lights will be on at a time. If you are curious about the GLSL code that goes into making these so-called events, I would recommend checking out the first video in this Timecode Touch Designer tutorial series. From here, we are going to go one base deeper into an event container that I have created here, and we will link up our beats to the animation. Okay, we start connecting the beats to the animation. Of course, with the beats on the left-hand side here, we are pulling in our 16th notes coming off of our Ableton Link. The nice thing about the 16th notes is it gives us extra precision in our animation comp, but it also does not cook every frame. It's actually only cooking every 16th note, so that saves us a lot of processing power. This section beat is the number of the beats in each section. Each section starts at 1 as it's loaded in. And so we're counting across, and this animation comp is almost exactly the same as a typical animation that you would get off of the app create dialog, but the only difference, it's been modified with the keyframer component to add an extra base here that includes all the keys, and the keys are, each channel gets its own DAT. So every time a song is loaded into the deck, the keyframes come with it, and they progress through these 16th notes. And the 16th notes are being sent into just a null with the number of in their counts that they have accumulated, and they are triggering an event out of a list created in a class that I called the Event Annie list. Every section demonstrates what events are currently on, so I'm just going to shoot it back to the beginning of the song. Now that's kick drum 1 here. If I go to event 1, we have kick drum 1. And it is here. I could change this to read duration, and we can see that it's 2 beats here. Back to name, just to read it, make sure it's all linked up properly. And so every time one of these goes on to off, we are creating an event off of an extension that triggers the proper index, sequence, tail, all that stuff to make sure it's looking the way we mean for it to look. Let's take a peek into some of the Python code that we use to make unique events coming off our Python dictionary for each of these decks. If you look at this Python code coming directly off of our chop execute at the end of this animation chain, we are calling a deck parent shortcut, and then a class extension. We're calling that from deck extension module, which lives right here up 2 levels at the same level as our deck. I have that opened right here. And we are calling a function called create Annie events. That's up here at the top of our screen. This is exactly what we did in video 2. We talked about this at length. So if you would like to understand some of the basic concepts that are being used here, this is just a much more fleshed out version than we could create in 1 hour. So we are calling the event Annie list, which, as I scroll up to the top here, pardon me, our event Annie list is calling the module text1, and that is in relation to our chop execute. So I have a text1 dat on the same level here inside of our events base inside of deck1. So this is a separate script inside of 4 different decks here. We are creating an animation list out of the lister values that we have called and changed in our UI. So that includes what we were talking about earlier: duration, intensity, trigger. I mentioned hue at the beginning of the session, and this is kind of what I'm talking about. I use the toggle values for floor, tubes, and cans, and then depending on the vec3 sequence here, I push out an integer value that I'm sending in one channel for the sample in an event chop. So although I'm taking these 3 dictionary values, I really only want to receive one integer value. And that is what dictates if a fixture bank accepts the event as triggering a light. Instead of having 3 different event chops, I just have one event chop that packages its bank parameter value, essentially. As I scroll back in our deck extension, create Annie list is up here. It is asking for the channel value and the channel index. The channel index is to determine which event in the Annie list is being referenced at a time. So the channel index is coming off of this math, or rather this null event generator, and then it will give you the value is the count that we are using. So if it's cycling over 4 lights, it'll cycle over and over and over again. So for each event that gets called, we are asking for the details that we have determined inside of the lister UI component. There are 2 variables that we are calling from a table dat that exists, and these are 2 index values we use as a logic tree, and we never want those to change in the UI because they are used across many events, and we don't want them to change in one place and then subsequently change all over all of our different songs. if we look at line 138 to 141, we are determining if a stem value is associated with the animation. And then if the stem is off, we will not send the event. At the very end, we are sending the event. We have packaged up all of our variables as samples at the end of line 146. We do have an error in this script as I was recording it where we are receiving the duration of each event as a string and we are trying to multiply it by a float. So in order for this to work properly, we want to multiply float by float and convert our duration string into a float. The last script that I think is worth elaborating on is the script that we use in our lister. These are the callbacks inside of the lister. And I'm just going to kind of scroll through them a little bit so you can take a glimpse at what we have going on. This is how I open up the menu options when I right click on a value. So if I right click on these names, then my background options come open. And if I left click on these names, my regular events pop open. I can drag these over into a spot and it lays it out. Then from there I can change it and switch all the slots. If I right click on it, I get the slots. And on this on right click, if the column name equals slots, my name list equals the slots. These are the left click options. Here's the on drop script is pretty useful. This is the drag and drop script that pulls the events into a new dictionary. This is the script that saves a new dictionary value when we edit a table, edit the lister. You can double click on this stuff and change the tail and so forth. Just a word of advice. If you click it in here and it starts having a cursor, that messes things up for me. I'm not even going to show you because I have to refresh the whole lister and it gets goofed up. So if you want to change a value in the lister, make sure you are in a spot where it's highlighted before you. Maybe I'm putting a decimal in it afterwards and I wasn't, or I think it's when I backspace on it. I just don't even mess with it. You know how it gets sometimes a little finicky. I don't change anything unless it's highlighted like that. Let's see. Maybe I'll elaborate a little bit more on if the column name is cans or floor or tubes. This goes back to the big bad lister topics that Ivan and Matthew put together. I'll put the documentation in the comments once again, but super useful. This lister component is just like uber customizable. So now I can click these in and off to make them go. Delete my event. Yes. I'm going to wrap this video up right here. I feel like there's a lot of different directions I could go to elaborate further. I'm sure there's lots of questions that may have popped up over the course of this video. So if you have anything that you'd like me to describe further, please leave a comment. Subscribe to check out the next videos. I'm hoping to do some more videos on some tricks and tips I use around keeping the clock in time. Some further videos to describe the dictionaries that we're using here, and especially some lister tips. I've learned a lot over the course of filling out this video. In actuality, this tutorial series has been just like a kick in the ass to polish this up and make it better for other people to use. So hopefully in the future we'll be able to distribute this, but for right now, I'm going to keep it in my pocket, and hopefully you can use some of these tips and tricks to make some of your own systems that work like this as well. Talk to you later. Peace out.